Hello students, welcome to Sri Jendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 6 of a unit Magnetism and Matter. So let's begin with today's class. In today's class we are going to discuss a very shorter amount of a very short topic but a very important one. It's a concept of null point. So what is null point and how do we find it out? Let's have a look. Basically, it's a superposition of magnetic fields. While I say superposition, that means we are having more than one magnetic fields at a particular location, and then we need to use a vector's law of addition to find out the net magnetic field. That is what we call as a superposition of magnetic field. So first, it's a neutral points or null points. Let's say that in the combined field, why? Due to bar magnet and horizontal component of Earth's magnetic field. I am having a two components of magnetic field. One of them is due to the Earth's magnetic field and the another one is due to bar magnet. The point in the region around a magnet where its magnetic field is exactly neutralized. That means a net would be a zero, exactly neutralized by the Earth's magnetic field, that is called as the null points. I hope you understand that we want to find out that locations or the distance of that location from the bar magnet at which the net magnetic field due to this bar magnet and Earth's magnetic field will be a zero. This is my requirement while discussing this. Let's begin. First case, it is the north pole of a bar magnet pointing towards the geographical north. So north is pointing towards the geographical north. Let's have a look. This is my bar magnet. This is the north pole. This is the south pole, and this is the news that you understand. It's a north, east, west, south. So north pole of the bar magnet is facing the towards the geographical north. So when a magnet is placed in the magnetic meridian with its north pole facing geographical north, the combined magnetic field lines due to Earth and the bar magnetic are as shown in the figure. So for magnetic field lines due to this bar magnet is from north to south. Let's have a look. This is the situation that from living from north and reaching to the south, it is living from north and reaching to the south, something like this. Yes, this is the magnetic field lines due to north south of bar magnet, and this lines are due to the geographical north south locations. Yes, so what we can understand is along the axial line on both the sides the two fields have same directions, and the magnitude of resultant magnetic field is the sum of the magnitude of the two fields. So on the axial line we don't have any null points. On the axial point everything is going to be added. If you observe this carefully, that means they are just the case of addition, and you cannot produce a zero result by adding a two vector quantities. Yes, but on the equatorial line the directions of the two fields are exactly opposite to the each other. So on the equatorial line the points n1 and n2, which are equidistant from the center of the magnet, the two fields are equal and opposite. Let's have a look at this position, at this location, from this n1 and n2. These are the two locations where the magnetic field due to this two, that means the magnetic field due to this bar magnet and magnetic field due to the Earth's magnetism is equal and opposite to each other. So if they are opposite to each other, we can have the location of null point. How will I find it out? Let's understand that. Let's suppose average distance of n1 and n2 from the center of the magnet is d. Then what I can write, it's a b of the magnet, that would be equals to bh. It's a horizontal component of Earth's magnetic field, so this is bh. Now what I understand, this b magnet, it is at the equatorial line, and when I say it is on the equatorial line, I can have it's a mu naught by 4 pi into m upon d square plus l square to the power 3 by 2. If I have considered that this magnet could be treated as a short magnet, then this BH could be written as mu naught by 4 pi multiplied by m by d cube. I hope this is clear. Is it clear? Is it? So when and when north pole of the magnet pointing towards geographical north, I am having null point. I am having null point on equatorial line. Yes, and that can be that the location can be find it out. The location can be find it out using the magnetic field on the axial line. I hope this is clear. Yes. Now let's rearrange this. That in this situation, north pole of the magnet is pointing towards the geographical south. So exactly the opposite. I have reversed the direction of the magnet. It is something like this. So when a magnet is placed in the magnetic meridian with its north pole facing geographical south, then the fill lines of the resultant magnetic fields are shown in the figure. Yes, this is my magnet. This is my magnet, and this is just the northeast, west, south. And I have put my magnet in the direction such like this, and the direction of magnetic fields have been shown. So if you can observe this very carefully, here two locations are there. Which could be having the opposite direction. Let's first look at this. Set on the axial line, the directions of the two fields are exactly opposite to each other, and on the equatorial line, the direction of the two fields at all points are same. On the equatorial line, there would be a no location of null point, because because every magnetic field is having same direction, and if every magnetic field having the same direction, that means they are going to add it up, not subtract one. So so if they are going to add up, they cannot produce a zero result. But on the axial line, we could have a null point. So if the average distances of n1 and n2 from the center of the magnet is t, then the magnetic field due to magnet is equals to magnetic field due to horizontal field, and magnetic field due to magnet could be given as it is on the axial position, so that could be written as mu naught by 4 pi multiplied by 2md upon d square minus l square whole square. That should be is equals to bh. So if I consider a short bar magnet, then I could have it's a bh. That should be is equals to mu naught by 4 pi into 2m by d cube. This is the horizontal magnetic field. Have you got this? Are you sure? So in this situation, null point will be obtained on axial positions. I hope this is clear. So in this situation, null point will be available at the axial position. Now let's suppose we will find out a neutral points in the combined field due to isolated magnetic poles. Let's suppose we have two poles. This, when I say isolated poles, that means you understand we have two monopoles, and due to this, let's suppose I need to find out the null point. How will I do this? So what we can understand is when two magnetic poles of pole strength m1 and m2, we assume that m2 is greater than m1, are separated by a distance d. The distance of neutral point from the weakened pole strength m1 is, so this is something like this. These two monopoles are there. One of them m1, another one m2. M2 is greater than m1, and their distance is given. Let's say this. So what I can do is that let's suppose I need to find out this x. So what I need to do is I need to write down the magnetic field due to this two poles. Let's say this is the B1, magnetic field due to first monopole, and let's say this is the magnetic field due to second monopole. So if I want to write down the B1, that could be written as mu naught by 4 pi into bracket M1 divided by x square, and this B2 could be written as it's a mu naught by 4 pi multiplied by M2 divide by d minus x whole square. So this is B1, this is B2. Yes, and now it's a B net that should be equals to 0. This B net should be equals to 0. So what I need to do is I need to just compare this B1 equals to B2. I hope this is clear. Yes, so this is the case. Let's suppose when I have derived it, I am having this. It's an x is equals to d divided by root of m2 by m1 plus minus 1. So why plus minus? Because I have chosen that it is possible that both the poles are of north pole, and if they both are of north pole, they both must be having the positive polarity. It is possible that both are would be of south pole. Yes, so if this is the case, then it would be of negative polarity. So if both are of like poles, it would be an addition. Both are of south pole, then even it would be addition. But if one of them is positive, another one is negative, it's a north and south kind of thing. Yes, one of the poles is north pole, another one is the south pole, then it would be an under root of m2 by m1 minus of 1. Yes, do you understand this completely? Are you sure? Are you sure? Can you do this? Can you do this? Can you? Great. Next. Neutral points in the combined field due to short bar magnets. So let's say if we have two short bar magnets of magnetic moments m1 and m2, and the thing is that m1 is less than m2, are placed at a distance d as shown in the figure. So if neutral point is formed in between the magnets, then it would be possible to have a b1 equals to b2. So how this will possible? Let's have a look. This is my one of first bar magnet, this is my second bar magnet, this is south, this is north, this is north, this is south. So if I look at this position, it is the actual position for both. This is south, this is north, so its magnetic moment will be in this direction, its magnetic moment will be in this direction, m1 m2. So for the actual position, direction of magnetic field and direction of the magnetic field, direction of the magnetic moment m and direction of the magnetic field will remain the same. So this is the direction of b1 and this must be the direction of b2. As I can understand that these two have opposite directions, these two have the opposite directions of magnetic field, I can write that their net magnetic field could be 0 and neutral points can be formed. So if this is the case, let's write it down. So for the first b1, it's a mu naught by 4 pi into 2m1 by x cube. For the another, it's a mu naught by 4 pi into 2m2 upon d minus x whole cube. So this mu naught by 4 pi could be cancelled out. This 2 could be cancelled out, and this could be solved and get it done for the x. So this x is equals to d divided by m2 by m1 to the power 1/3 plus 1. Is it clear? So this is the case. If neutral point is formed in between the magnets. Now let's discuss the second case. If neutral point is formed outside the combination, then what would be the situation? If neutral point is formed outside the combination, let's suppose this is the location where neutral point is going to formed. So in this situation, what I'm supposed to do is, it's a mu naught by 4 pi into 2m by x cube. That would be equals to, for this distance will be equals to d plus x. So that could be given as mu naught by 4 pi mu naught by 4 pi into 2m2 divided by d plus x whole cube. So this mu naught by 4 pi, this mu naught by 4 pi can be gone. This 2 could be gone, and I have been left with the x, which is equals to x is equals to d upon m2 by m1 to the power 1/3 minus of 1. I hope this is clear. Yes. One more thing, no null points are obtained. No null points are obtained when unlike poles of the magnets are placed closer to each other. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Great. Let's have a look. That suppose we have a bar magnet over here, and this is the north pole of bar magnet, this is the south pole of bar magnet. If I look at the geographical conditions, then this is the news, this is NEWS. So this is north, this is east, this is west, this is south. So if I have been asked that find out locations of neutral points due to magnetic fields of bar magnet and Earth's magnetism. So this is the requirement. We need to find out the locations of neutral points due to magnetic fields of bar magnet. So for this north pole and south pole, this is the situation where north pole of bar magnet is facing towards the geographical north. As we have discussed currently only, that we have a null points over here only, and no null points are obtained on the axial position, but we have them on the equatorial position. Let's say this is D. Yes, ideally it is from the middle of the magnet. So if it is a short magnet, then I can write it's an BH. It is something like that could be equals to mu naught by 4 pi multiplied by, it's an equatorial position, so it's an m by d cube. A same thing is true for this as well. Yes, so no null points are obtained on the axial position, but for equatorial position, this is the situation that we could have equatorial positions, and we could have a null point on the equatorial positions. I hope this is clear. So this is B is equals to mu naught by 4 pi into m by d cube. Generally they will provide me the BH, and this distance can be calculated very easily. I hope this is clear. Now let's look at the second question. Suppose the question says that if we reverse the direction of bar magnet discuss about null point. So initially the situation is north pole of a bar magnet was facing towards the geographical north. Now they said that the direction of the magnet has been changed. That means initially it was north pole, now this is south pole, and the geographical location will remain the same. It is for obvious, it's a north, east, west and south. Now in this situation we are not having any null points. We are not having any null points on equatorial positions. But the situation would be something like this. This is south, this is north, this is north, east, west, south. Yes, null points will be obtained at axial positions. I am having a null point at here. Let's understood that this is the distance t, or you can choose this. Then it's a BH, it's a horizontal component of magnetic field, will be equals to magnetic field at the axial position due to this bar magnet. It's a mu naught by 4 pi into 2m by t cube. I hope this is clear. Is it clear? Is it clear? So please do remember these things, that when bar magnet is, or the the south pole of the bar magnet is pointing towards the geometrical north, then it will be having a null point on the axial positions. I hope this is clear. Is it clear? Is it? Great. Let's have one more question based on this null point. Let's suppose we have this as a south. Yes, this is south pole, this is north pole. Let's write it as 1 and 1. And this is north pole, this is south pole. For me, this is the first, this is the second magnet. M1, it's a magnetic moment of first magnet. It's a 20 ampere into meter square. And for second, M2, it's a 10 ampere into meter square. The distance between these two, it's 30 meter. Yes, the distance between these two, it's 30 meter. So what the question is that find out null points. And one more thing they are providing, it's consider the bar magnets as short dipoles. So they have already provided that these are the short dipoles. You can take them as a short dipole. What do you need to find out? You need to find out the null points. How will I do this? So what I understand is that one of the null point will be obtained between these two. So let's connect them. Yes, and let's understood that this is 20 ampere into meter square, this is 10 ampere into meter square. Let's suppose a null point would be obtained at here. Let's assume this is x. So if this is x, this would be, for obvious, it's a 30 minus x. Now let's find out the direction. So this is south and north. If I understand that this is the magnetic moment of first, so even this would be at this point, direction of magnetic field 1 will be in this direction. This is south to north, this is the M2, and magnetic field due to this would be in this direction, this is P2. I hope this is clear. Now let's just write down the value of the B1 and B2. So this B1 could be equals to mu naught by 4 pi multiplied by 2m1 divided by B1, it's a 30 minus x whole square, and B2, that would be equals to mu naught by 4 pi multiplied by 2m2 divided by x square. So this is B1, this is B2. What I want it's a B net that should be equals to 0. If I want B net should be equals to 0, so then it would be B net is equals to 0. That is only possible if B1 equals to B2. So this is equals to mu naught by 4 pi multiplied by 2 into m1 divided by 30 minus x whole square. This is equals to mu naught by 4 pi multiplied by 2m2 divided by x square. This mu naught by 4 pi, this mu naught by 4 pi has been gone, this has gone. Now my m1 was 20 divided by 30 minus of x whole square. This is equals to m2. m2 was 10 divided by x square. So this is 10 2s are 20. So this is 2x square is equals to 30 minus of x whole square. Let's take a square root on both the sides. It is of root 2x is equals to 30 minus x. So this is root 2x plus x is equals to 30. So this x could be equals to 30 by root of 2 plus 1. This would be the final answer. Have you got this? Have you? Do you understand this? But this is only one of the location. This is only one of the location. And this is the location if null point is being obtained between these two. Now let's discuss the second condition. Is it is something like this. Let's suppose this is south north, yes, and this was the another, and this is the point where I will obtain the null point. This was the n2, this was the s2. So for this, magnetic moment is in this direction. For this, magnetic moment is in this direction. So b2 will be in this direction, b1 will be in this direction. I hope this is clear. Let's find out the distance. This is, let's say, x. If this is x, this should be the 30 that they have been given in this. So b1 would be equals to mu naught by 4 pi multiplied by 2m1 divided by 30 plus x whole square, and b2 that would be equals to mu naught by 4 pi multiplied by 2m2 divided by x square. What I want a b net to be 0. I want a b net to be 0. If this is 2b0, then b1 must be equals to b2. This is mu naught by 4 pi multiplied by 2m1 divided by 30 plus x whole square. This is equals to mu naught by 4 pi multiplied by 2m2 divided by x square. This has gone, this has gone, this 2 has gone, this 2 has gone. m1 it's a 20 divide by 30 plus x whole square should be equals to m2. It's a 10 by x square. So it's a 10 2s are 20. If it is the case, then this is equals to 2x square. This should be is equals to 30 plus x whole square. So this is root of 2x is equals to 30 plus x, and thus it's an x which is equals to 30 by root 2 minus of 1. This is the location. If null point is being obtained at one of the side of the bar magnet. I hope this is clear. So I hope now you will be able to find out the null points. Yes, this is very important topic as it contains a very less amount of application. This will help us. Yes, because this could have a command. We could have a command of it very quickly. So let's just wind it up this session over here. Yes, please practice this kind of questions. This will help us. Thank you. Have a good day. Take care.